Assalamualaikum, my name is Ahmad Aziz Imran and today I will present our study on plant-based CREAMNUT ice cream. In this research, we focus on isolate soy protein or ISP because ISP has a good emulsifying and water-binding properties that can influence freezing structure and melting behavior. We compare three formulations with different ISP level and one control to evaluate melting rate, viscosity, texture profile analysis and nutritional improvement. Through this comparison, we aim to identify which ISP level provide the best physical quality for our plant-based CREAMNUT ice cream.
Assalamualaikum, my name is Siti Norazah binti Jemakoin. I will present our problem statement. The first problem statement is the influence of formulation on the viscosity of non-dairy ice cream. There is limited research on the viscosity-related properties of non-dairy ice cream, especially those made from the cashew milk and coconut cream. Understanding how formulation affect flow behavior and meltdown is important for improving texture and stability in plant-based frozen dessert. Our second problem statement is limited research on the melting stability of non-dairy ice cream formulated with plant-based protein. Although cashew and coconut-based desserts have been studied, the effect of plant protein like isolated soy protein on melting rate and texture is still not well understood. The third problem statement is texture and iciness issue. Another issue in non-dairy ice cream is excessive iciness, which results from weak fat destabilization or low serum phase viscosity. Without optimal structure, the ice cream may have a coarse texture. The third problem statement is texture and iciness issue. Another issue in non-dairy ice cream is excessive iciness, which results from weak fat destabilization or low serum phase viscosity. Without optimal structure, the ice cream may have a coarse texture.
Very good morning to respected panel and everyone. My name is Shaila Sesegren, number 33DTM23M19. The first objective is to analyze the viscosity of the different formulation containing isolated soy protein to see how it influences thickness. The second objective is to investigate the effect of soy protein concentration of melting stability. Next, we aim to assess the textural characteristics including hardness and adhesive to identify which formulation is the most stable and pleasing texture. Lastly, we will determine the nutritional composition such as energy, fat, protein, carbohydrate to compare our result with existing commercial plant-based ice cream.
Our first analysis is viscosity. For viscosity analysis, samples were prepared based on each formulation and tested using Brunswick consistometer. The flow distance were recorded after releasing the gate to determine consistency and flow rate, which help evaluate this product structural stability.
For melting evaluation, we use the wire mesh drip test. We prepare 20 gram sample for all formulation. Each sample was shaped in a standard mold, weighed and placed on a wire mesh position over a table. The drip mesh was recorded every 5 minutes up to 30 minutes or until full melt. And photo we also taken to observe shape retention. From the total drip collected, we calculated the melting rate in gram per minute, allowing us to compare melting behavior between ISP level and the control.
Third analysis is texture profile analyzer. For texture profile analyzer, prop review is 25 mm of cylindrical prop, penetration depth is 15 mm, force is 5 gram, prop speed is 3.3 mm, prop penetration speed is 3 mm. Procedure for texture profile analyzer is first the sample was prepared at desired temperature which is -5, prop attached to the instrument tare, test parameter set, prop penetrate sample, test repeated for 4 samples, which is control formulation 1, formulation 2 and formulation 3. Equipment we use for texture profile analyzer is 25 mm of cylindrical prop and texture analyzer.
For nutritional analysis, the samples were tested in collaboration with Johor Toyiban laboratories to determine protein, fat, energy content, and carbohydrate, and to compare our formulation with commercial non-dairy ice creams. The result revealed that formulation 3 had the highest viscosity, but it becomes softer after freezing. Meanwhile, formulation 2 achieved the most stable consistency and smooth flow. Based on year 2024, we reported that moderate viscosity contribute to better melting resistance.
Based on the data, all 4 samples show an increase in melting weight over time. F1 melted the faster followed by F2. The control melted quickly at the beginning but became more stable later. F3 recorded the slowest melting rate throughout the 30 minutes, indicating better structure stability. This showed that ISP level influenced the protein-fat metric, where the higher ISP in F3 helped retain structure and slow melting compared to other formulations.
For the result of texture analysis, we found that control was the hardest and most solid, while formulation 1 was the softest and formulation 2 and 3 was in between. But formulation 3 was slightly firmer than formulation 2. In terms of cohesiveness, the control sample broke apart easily, but formulation 3 is held together the best, meaning it had a stronger and more stable texture. This could be because formulation 3 had a better balanced ingredient, giving it denser and smoother structure. On the other hand, formulation 1 is the softness made due because of higher air and moisture content. Overall, formulation 3 showed the most desirable texture as it was both stable and smooth compared to other samples.
The nutritional results show that CREAMNUT ice cream had the highest protein content compared to commercial brands like Sankaya and Kalava. This improvement was due to the addition of isolated soy protein, which helped enhance both the nutritional profile and texture quality of the final product.
From this study, we can see that isolated soy protein has a clear impact on CREAMNUT ice cream quality. ISP increase viscosity and create a more stable structure which reduce breakdown during handling. ISP also contribute to slower melting, improve shape retention during serving. In terms of texture, plant protein increase firmness but still maintain acceptable mouthfeel. Overall, this suggests that CREAMNUT has the potential to be a healthier non-dairy alternative with a more favorable nutrition profile compared to some commercial ice cream.
Lastly, for conclusion, our objective was achieved through this research. This study shows that formulation had a strong influence on the viscosity and overall quality of non-dairy ice cream. By increasing the concentration of isolated soy protein, the viscosity and the melting rate improved compared to contract-based control. This helped to solve the problem of poor melting consistency commonly found in plant-based ice cream. The addition of isolated soy protein also reduced the aggressive icing, giving the ice cream smoother texture and better mouthfeel. From the texture analysis, we found that the plant protein formulation affected hardness and adhesive, producing a more desirable product. Overall, this research proved that optimizing plant protein formulation can enhance texture, melting stability, and nutritional value of non-dairy ice cream. Thank you.